name is Jim Paterson. I'm a principal of a mining exploration house from Vancouver, Canada called Discovery Group. And we've got some great panelists today. Our topic is deploying new technologies to leapfrog towards advanced mineral production. So we've got 5 leaders in technological innovation that will be sharing ideas today. We'll get started right away with some intros. We'll start at the far end with Mr. Katase.
Jim, I'm Hirofumi Katase, and I served in Japanese METI, Minister of Economy, Trade and Industry, for 35 years. During my tenure, I was deeply involved in a wide range of R&D, such as aerospace and energy. I also had the privilege of overseeing Japan's entire R&D programs. 7 years ago, I concluded my government service as Vice Minister, and I joined IPAS. We are pioneering the applications of high-pulse power technology across a broad spectrum of industries, including energy, mining, and beyond. So I look forward to sharing what we are doing today, later. Thank you.
Thank you. Adam?
So I am Adam Simon. I'm a professor at the University of Michigan, where I do research on the formation of different types of critical mineral ore deposits. And using the results of R&D, we spun out a company about a year ago that uses new technology to expedite discovery of critical mineral resources and improve heap leaching operations.
Great. Pia.
Hello, I'm Pia Karhu. I come from Metso, and I'm heading the minerals business area at Metso. And for those of you who don't know Metso that well, so we are a technology company, service company operating in the mining and aggregates industries. And our strength is truly the wide offering that we do have, from comminution to separation to tailings management. And then also we have a strong offering on the metals refining area, so quite a wide offering. Of course, core to our business is the renewal of our technology portfolio and serviceability of our technologies. So that's the angle where I'm coming from to this discussion. Great to be here today.
Thank you, Pia. Don?
I'm Donald Sadoway. For 44 years, I was a professor at MIT, where my area of research was in applied electrochemistry, and of relevance to today's session, a lot of metallurgical extraction technologies for aluminum, magnesium, titanium, rare earths, and so on. And I've since stepped away from MIT and started my own company called Sadoway Labs, where we're looking at radical innovation in metals extraction from different sources of ore.
Thank you, Don. Pascal?
Thank you, Jim. I'm Pascal Lacourie. I'm the CEO of EPC, and I'm the partner of our joint venture, local joint venture, MCS, with our partner, MCC. Abdulaziz with us today. I've been on the chemical industry since 25 years, on different positions of management strategy position for increasing our footprint, EPC footprint in Middle East, Asia Pacific. Before I was in Europe and South America. EPC, it's a company, and MCS, we are specialized on explosive manufacturing and all the service associated, drilling, blasting, so mainly for extraction in mining. So our motto is enabling mineral sustainability, so we can talk about it a bit later.
Excellent. Thank you. So we're in for a real treat. We have an incredible lineup of experts. So just reminding everybody about the topic. It's incorporating technology to really advance the mining sector forward into production. So starting with you, Mr. Katase, can you tell us a little bit about the application of pulse power technology in the mining space?
So first of all, high pulse power, or HPP, is a revolutionary way to use electricity. It compresses a very small amount of energy and releases it at extremely high power. For example, HPP can harness energy equivalent to that of stored in your watch to generate 1 gigawatt of power for just 1 millionth of a second. We have industrialized this application of HPP in a wide range of areas, but today I will focus just on mining. Using HPP, first we have developed a Typhoon, advanced geophysical survey system. And this enables us to survey 5 times deeper and 100 times faster than conventional method. It's already commercialized, and in Saudi Arabia, we are in partnership with Marden to explore 48,000 square kilometers. Secondly, we are also developing a cutting-edge drilling technology, which combines HPP with a conventional PDC drill bit. And so far, we have already achieved 70% cost reduction as compared with commercial technology, and we are planning to industrialize it by the end of 2027. Lastly, we are now, and this technology is initially targeted for oil and gas and geothermal, and this technology can be applied for mining applications as well. Lastly, we have advanced rock crushing technology that could cut energy consumption by 80% from the conventional one. And finally, I'd like to share a very small secret about how we approach in deploying these technologies to truly leapfrog the industry. And this is that we are trying to be a user instead of a supplier of technology as much as possible, because this will be the quickest way to deploy our technology and also maximizing the value of a new technology. Thank you very much.
That's great, thank you. I'm going to mix it up a little bit and call on Don to tell us how he thinks we can leapfrog using technology the industry forward for mineral production.
Well, I think
Don.
that
Yeah.
I think that the leapfrog is to consider vertical integration. You know, if you take a look at all the minerals that we have in society, very few of them are used as minerals. They're used as metals, and sometimes as fine ceramics. But it's very rare that you pull something out of the ground. I like to tell Robert Friedland, you cannot draw copper wire with copper ore. And so I think that there's opportunity for the industry to vertically integrate right from the mine face to the final metal product. Why not? So that's my short take on it.
That's great, thank you. So Pia, can you tell us a little bit about the opportunity in coarse flotation?
Yeah. So as Metso, of course, we look at improvement opportunities across the whole minerals processing chain, and there's interesting opportunities across. One of the topics that we are working on at the moment is the next generation coarse flotation solution. I mean, coarse flotation is not something new. The concept has been there for 20 plus years, but also the challenges of the current applications are known to the industry. So we have taken the challenge together with our customers to look into what could be the next generation coarse flotation solution, and quite interesting concept that we are working on at the moment that allows us to solve the current channels of fines and also the excess water uses as part of the process. So I think very interesting development area. It can reduce energy consumption of about 30%, up to 30%, reduce water usage, and all of that. So can be quite an interesting solution for the mining companies. And of course, the interesting part is also that what is the whole flow sheet around the coarse flotation and how we can also then reduce the footprint of the whole mining operation. So looking forward to further developing that one. At the moment, we do have a pilot plant as part of our own operations, and we are working together with a few customers to actually bring that to our customers' sites.
Excellent, thank you. Pascal, tell us about the digital backbone.
Digital backbone. So that's something we develop, and we have really tailor-made, I would say, with our customer to improve the ore extraction. So that means when we talk about digitalization, we have to make sure all the stakeholders, and I'm talking about the mining operator, mining contractor, which are a bit different, and they should have the same objective, of course, by increasing the profitability and the productivity, but as well to work on for the sustainable extraction operation. So we are with our Vertex integrate platform. We plug different software and hardware to measure, to collect data in order to analyze and optimize the operation from especially on the drilling and blasting operation. But as you may know, I'm sure you know, this part of the extraction has got a big impact on the downstream operation. So the objective is to reduce the ore dilution, and on many cases we managed to reduce by 30% the dilution of the ore, because you have to respect the resources, of course, and we have to respect as well the environment, and to decrease the waste, the tailing, for example, to decrease the gas emission, in order to increase the acceptability of the mining extraction. So that's our digital solution is something has been built, designed by blast engineer for blast engineer. Okay, so something easy to implement. Yes, our customer and one of our big customers here in the Kingdom is Ma'aden, and we try to help them and to achieve their objective, because we've got a common objective.
Right. Excellent. So we're talking about mining. Before you find the mine, how can we focus our efforts? So Adam, maybe talk to us a little bit about hydrogeochemical opportunity.
Yeah, so what our company does is generates primary data using the composition of ground and surface waters collected from anywhere on Earth. We measure the isotopic abundances of every metal from lithium to uranium, and we have used data from every type of copper, gold, silver, zinc deposit to train a model that allows us to use the composition of water to fingerprint specific sulfide minerals in the subsurface at 100% accuracy. So if a mining company is interested in searching for a deposit that contains chalcopyrite and supergene chalcocite, using only water from an area, we can tell you with 100% accuracy, yes or no, that water chemically interacted with chalcopyrite and supergene chalcocite. And we can distinguish metals in water that are simply the result of background. We also have used the methodology to help improve heap leaching. So we are able to analyze pregnant leach solutions, and we can use the composition of pregnant leach solutions to tell a mining company the exact sulfide and oxide minerals that are being weathered in the heap, which is extremely valuable because heaps are notoriously heterogeneous, both with respect to mineral abundances, mineral type, and grain size. So we can help companies identify which minerals are being weathered, which allows companies to tailor the chemistry of the lixiviant to maximize the production of metals from a heap. And then lastly, we use the methodology to help companies fingerprint metals in the near mine environment. So using water samples from monitoring wells, we can use the metal isotopic composition of those waters to unequivocally distinguish metals in the water that could be coming from mining operations, including tailings, from metals in the water that are simply present as background. And we're the only company in the world that can offer these three forms of technology.
Very exciting. So we cover all the entire evolutionary scale of the mining sector here. So I'll start with you, Pia. With all these great ideas, how best do we incorporate technologies and get them into the ethos and actually commercialized? What's the best way, you think?
Yeah, I think, again, in this panel and during the days here in FMF, we have heard a lot about innovations, ideas, and I think the breadth of it is very exciting.
Yeah.
So then the key question really to me is that how can we accelerate the innovation development and then the adoption in the market? because the targets are clear in this industry and in this sector. So how can we together really accelerate the adoption of the marketplace? And I think in our discussion, innovation is bigger than one company. We as Metso can do only so far, and I think you share the same point of view, and truly it does require collaboration already on the innovation phase. So at least what we have learned in our innovation projects is that earlier that we involved customers or partners on the ecosystem, the quicker we are actually able to develop the innovation and then actually bring it to the market as well. So I think that's crucial. These innovation projects tend to be very long, I mean 3 years, 5 years, etc. So the key thing in my mind is that how can we half the time to market with all those great things that we can offer for the customers.
Yeah, I mean, so a lot of great ideas are trapped in the closets of universities around the world, never to emerge. Mr. Katase, you made a very good point that you were saying you try as much as possible to use your own technology commercially, and in a way you're lucky to be funded in order to do that. Maybe talk to us a little bit about, personal usage of your own technology.
Yeah, so we have established our own mining company.
Yeah.
And now it has been spun out as Ivanhoe Electric, listed in New York Stock Exchange. But the basic idea is that if we have a very disruptive technology, it's very hard to persuade conventional players to adopt it. At the same time, if we can afford to establish our own mining company, this company will be the best in the world. This is the basic idea.
Right. Don, how does that fit with your vertically integrating statement you made earlier?
Well, I think that people are hesitant to adopt radical innovation because it's fraught with risk, and people would like to innovate without risk. And so then I think the burden falls on the shoulders of the innovator to demonstrate at least the emergent scale. I mean, you can't expect, if I invent the technology for Boston Metal, and you say before an iron ore miner is going to look at steel making, I have to demonstrate steel making at billion tons per year. That's a pretty high bar.
Yeah.
But at the sort of entry level, where people will say, I think that can scale. But the burden is on the shoulder of the innovator.
Yeah.
And that's why the university stuff doesn't go anywhere, because it's on the lab bench. That's not big enough. So I think everybody knows what the role is. Just get to work.
Normally we'd finish with that kind of strength, but we definitely want Adam to talk about it because he works at a university, so this is actually literal description of the life you lead. So talk to us about that.
Yeah, so it was about a year and a half ago that an academic collaborator and I tallied up about $15 million that we had raised from the US federal government to do research and development, and none of that was commercialized. So coming to conferences like this and meeting people in the mining industry and listening and trying to understand what could add value to the fully integrated mining supply chain, we decided to spin out the university R&D that otherwise, Don is correct, it would have just sat on a desk somewhere and never would have seen the light of day.
So Pascal, you're, just one second, Pia. Pascal, you're in industry. How often are you presented with technology from outside external sources, and how do you deal with them internally to try to adopt them?
We try to capture the benefit of the technology from the different stakeholders, in order to provide an integrated solution. That's absolutely key, because the part where we are struggling when you want to move things on the mineral industry, but it's the same on the cement industry or elsewhere. When you want to implement something new, you struggle on the management of change, because of course you have to adapt the operation in order to implement the new technology. So that's really, and it's like this in the kingdom, but it's like this in every country. You have to be close to your customer and to supply the service to make sure they get the best or the most of the innovation and the new technology.
Right. Yeah.
Yeah, I wanted to pick up on the great work that universities do in the front of innovation, and we actually work a lot with the universities as well. And because different kind of players are needed, so we really value the primary research that is done at the universities and also the lab scale testing. But then I think when players like Metso are then needed after that one is that we have the capability to scale something that is laboratory size to first the pilot plant size and then further on to commercial plant size. And actually, typically the questions that we are facing with our customers when we talk about innovation is that you know how large you can scale it and how fast. Mm-hmm. And then of course also the price point of the solution, the cost. And that's when the players like OEMs are critical to bring the experience and value add that we have on the table. And yes, the origin can be actually research done by the universities. And then furthermore, I mean, the version 1.0 is only version 1.0. Then the importance is that how does the technology perform actually in the production environment? What is the maintainability of it? What is the safety features of it? And that's when the development again starts. So I think that's really crucial part of the innovation is that you continue actually developing the concept and make it more cost efficient, more productive, more maintainable, etc. at the marketplace, because then that's when you really increase the value of it for the end users.
Yeah. Mr. Katase, would you say that the partnership that you formed here in the Kingdom was your largest scale to date?
Not quite, because the initial application of our Typhoon technology, the initial Typhoon was applied in Mongolia, right. Finding Oitorgoi copper mine. So this was first application. And since that, we are applying this technology around the world by ourselves. And of course, in terms of the size of the area, this Saudi Arabia project is maybe the biggest.
Excellent.
But this is just one case. We are doing the same with BHP, for example, in North America.
Okay. But this is a great example commercially of how your technology can be applied at a broad scale. It's very exciting. Dawn, do you have any closing words for us that will empower us and encourage us to go forth bravely?
I think we've had some excellent comments here from the other members. I would like to congratulate Adam for taking this step to jump off campus and make science in service of society. So that's good. And maybe I might say something that's a little bit harsh, but I think in some measure, much of the university research doesn't move off campus because it's not answering a question that anybody wanted the answer to in the first place. There's this natural tension at the university where the professor has to be a scientist and a scholar. And the goal is to make research that is publishable in the scientific literature. The other goal is to invent technology that is useful for technology's sake. But that's not necessarily what gets funded by the agencies. So it's remarkable that anything gets out of the university. So I'm very optimistic.
Great. Okay, well, please give our panelists a big hand. Excellent work, everyone. Great insight.